joining us on the Compute stage. I'm very glad to see that the room is getting warmer, it's getting crowded, and no wonder because now the competition is starting. We're going to kick off the Compute Challengers final. Before we start, let me quickly remind the rules of the competition. Each contestant, each pitcher will have 3 minutes to expose their idea, and then the jury will have 2 more minutes for questions and answers. If any of them goes over those 3 or 2 minutes, I'll let you know so that we can move on. For the jury, please keep in mind that before you ask your question, we would kindly ask you to present yourself so that we know who's talking. And let's run quickly over the 7 benchmarks you have to keep in mind. First of all, problem. Second, product and service. Third, go-to-market strategy. Fourth, progress and traction. Fifth, the team. 6, financing. And 7, sustainability. Well, no time to lose, so let's find out who's going to break the ice. Let's give a big applause to Gabriel Klein, co-founder and CEO of AdAstra Defense. Come up on stage with me. I'm going to wait until you are right next to me to let the clock start ticking.
Hello.
The floor is yours, and your time starts. You have a screen down here to see the countdown right now. Let's go for it.
Hi, my name is Gabriel Klein. I'm the co-founder and CEO of AdAstra Defense, where we develop autonomous firefighting drone swarms to detect and suppress wildfires before they spread. The secret to stopping a large-scale wildfire is by never allowing it to get large in the first place. Last January, the Palisades fire started close to where I live in California. It burned over 23,000 acres, destroyed about 6,800 structures, and killed 12 people. And that's not because we didn't have enough firefighters, but it's because by the time the first crew arrived, the fire had already won. That's the broken model. We built a new one. And completed the full ADOS software stack. We did this with 0 outside funding. This raises our first. Our co-founder and CTO, Hubert Krishovic, co-founded Infinite Realities and exited a $10.1 billion valuation. He also built autonomous drone swarms for DARPA. And we have 4 co-founders, including myself, 3 advisors with DARPA, Google, defense, and data center credentials. We're raising $3 million pre-seed. On a safe note, 20% equity, 18-month runway, targeting closing Q3. The funds will go to hardware development, ADOS development, and 2 to 3 paying agency pilots. This is an energy technology problem. Wildfires destroy transmission lines, substations, and renewable installations. They release up to 200 tons of CO2 per hectare. Early autonomous solutions protect the grid, and preserve the watersheds that feed hydropower. AdAstra is not adjacent to the energy transition. We are frontline infrastructure for it. Thank you.
So thank you very much. And now the time for the jury starts.
Hi there, my name is Gabriel Craw. I'm with Prelude Ventures. I'm from California. I totally get the problem. I believe in your technologies, the solution. Tell us more, though, about the market size. When you said 25 billion, like that's a real TAM number. What you can claim of that number, I feel is a little bit smaller. So talk about how you justify that.
Yeah, so as I was saying, we plan on starting with local departments and agencies. the majority of the fire departments that we can grab, the WI subset is about like 10%. And there's about 5,000 departments nationwide. So yeah, so what is that, 500 departments, something like that. Our swarm, we plan on selling from anywhere from 1 to 1.5 million per swarm, and then having our $200,000 to $300,000 software service annual. Hope that answered your question well.
Yeah.
So your revenue model is selling an upfront product, which is the drone swarm, and
Correct.
then also charging a recurring SaaS revenue. Is
Yes.
this something that your customers are already used to? Do you have an analog of service or product they already do this model for?
Right, so actually there's Seneca, who recently raised $40 million, and they do autonomous suppression as well. However, they don't have swarm capability like us to our extent. Again, we have about a swarm capability of 250. So yeah, they do exactly that, and they have an annual recurring fee and then a multi-year contract.
Okay, I'm afraid that we run out of time. We have such short time for everything, but it was a great presentation, Gabriel. Good luck, and thank you so much. Okay, let's move on, and let's welcome on stage Martín Concha Rubio, co-founder of CFO&CIO of Ainwater. Where are you, Martín? Okay. Okay, you have your countdown right there. 3 minutes.
There is it.
You have the slider there, and the time starts right now. Good luck.
Hi everyone, I'm going to pitch for Ainwater, the intelligence of water. So this is a typical picture of one of our users. Is a SCADA system that is very old, and we are working in the water utility sector in treatment plants, water production and treatment. And yeah, these obsolete systems are creating a lot of problems. It's an impact huge in all the utilities, but also is a very intense in energy. So we are working specifically into try to improve this in efficiencies of energy and other kind of operational costs. And of course, also it's important that this workforce is going out in the next decade, more than 50%, because the operators are getting old. So we are taking the data from the different systems that they have from online SCADA, but also manual data and lab data. We are merging this, and we are optimizing and giving predictive control recommendations using AI models merged with chemical modeling, but also with biochemical and physicochemical models of science. So we can give them recommendations, put it with agents that we have already built, and then we can have reduction of the cost, but also reduction of the water footprint, and improving water quality to decrease fines. And we want to go further in the next years to automate the control by our agents. So the TAM on Samsung is very big. Principal, all the wells and water facilities to work with, and we are starting right now entering to the European market. Myself, I moved from Chile this year in February here in Spain to enter in the European market. And well, our business model is very simple, an implementation fee and then a license annually, and the ticket is around 20,000 euros per year. And we are operating already in 100 sites, a little bit more, in 5 branches. Spain is the new one, with more than 20 customers, now in Peru as well. The team, we are very deep in different science background in the engineering team, more than 20%, the 80% are engineers, and we are 3 founders. Well, myself, I am in the innovation sector. Sorry. Well, about the impact that we have already done in the rural sector area, we are working in more than 54 rural communities, securing the time reduction in water supply in more than 50%, but also in the industrial sector. Typically, in the piloting that we have done, we, in average, give them around 10% of optimization in chemical usage and also energy use. And now, the last year we grew 5 times, and now we are in a seed round, more or less in the half. So I am inviting you if you would like to invest with us. Thank you.
Thank you so much, Martin. Time for the questions. Let's start down here, please. Thank you.
Hey, Martin, thanks for the pitch. It's Iris from Visionaries Tomorrow. I noticed on your slide that you have customers from quite a few very different industries.
Yeah.
So how do you make sure that the product is relevant for all these different types of customers?
Yeah, it's true. It's quite complicated. It's in a legacy market that we have, but well, there are two things. Happily, agent technology is rising. So we have been working with agents since 2024. And at the beginning, what you have to do is to have a methodology how to do these deep models. And typically we are working with the negotiation rules and the science-backed models merged with the MLs. And then the other and this is a methodology that can be run like automatically for each new facility. So, and the other part that is important is the integration. For the scalability, we work with different partners, IoT partners in local regions. That is how we can be in Mexico, Brazil, Chile, and Peru, and Spain by now. But the agents will be part of this automation and, let's say, automate the ETL process.
Okay, thank you. So basically by leveraging the models, you make sure it's relevant for both a Coca-Cola, but also a Colgate who might have a completely different process?
Yeah, typically the industry, at least, is not, they like the impact in the economical part. So most of the time is operational optimization is the add value that we are giving them.
Okay, thank you.
19 seconds.
Okay.
Very, very quick question and answer. Okay,
And applause.
done? You want to use those 10 seconds? No, thank you.
Yeah, thank you.
Okay, Martin. Well done. Very well done. Now we have our next contestant already on stage. Welcome, Rob Alexander, CEO and co-founder at AlumaPower.
Thank you.
You need your slider, and there's your countdown. Your time starts now. Good luck.
Thank you. Good afternoon, everybody. I'm co-founder, CEO of AlumaPower. We're deploying firm dispatchable power using scrap aluminum fuel. Today, you have to bring your own power when you build your data center. With most markets, diesel backup power is relegated to being emergency only. And that means it's really dead weight capital. At AlumaPower, we go beyond backup. So we can meet that tier 4 requirement for backup, same as diesel. But because we have zero emissions, we can provide flexible dispatchability. We've taken a very modular approach, containerizing our system, leveraging over 16,000 hours of testing. And that's how we get to gigawatt scale power nodes. We de-risked this technology with multiple field demos. First was back in 24, where we provided grid-independent power. We now have multiple military contracts, and this summer we'll be hooking up our aluminum air generator for the first demonstration with AI data loads. And we want to prove out that we can handle these wide swings that come with AI compute loads. Now, there's more than one reason the hyperscalers are excited about aluminum air. This is a model from a customer in California building a gigawatt facility. And when you optimize using a diesel backup generator, you're forced to build massive amounts of solar capacity and BESS. 4.5 gigawatts of solar, 820 megawatt hours of BESS. You add us into the loop, and all of a sudden, everything gets simpler and cheaper. You get a reduction of the solar field of 42%, 64% less BESS, which leads to a 37% total capital bill to do the same gigawatt power module. That means a faster time to permit. That means more sites are now available for data centers, which of course means more compute and more money. You're probably asking, where are you going to get all this scrap? Good news, there's enough oversupply of scrap today to firm up 85 gigawatts of new capacity. We're partnered with one of the largest providers in the world, and with a 2-year lead time, they can get to 100 gigawatt hours of capacity for the fuel supply chain. We have deep expertise within our organization, lots of experience in launching new companies, but we also have multiple billion-dollar strategic partners because we're not just building a company, we're building an ecosystem. We're here raising a $10 million convertible to accelerate that roadmap, also looking for other strategic partners that want to get ahead of the pack. Come join us and turn scrap aluminum into the new firm power that we need for next year's compute. Thank you.
Thank you so much, Rob. Let's go for the questions. Okay, that front row, please.
Lots of questions. I better be fast.
Hey, Rob. Thank you. It's Paul from Extantia Capital. Can you walk us through some of the basic performance metrics relative to other archetypes that your customers could use? Like what's the round-trip efficiency, power density, CapEx, and so on?
Yeah, so in that modeling, I'll use the numbers from that model. How's that? That model chose us at 2 times the price of a diesel generator, okay? And 50% higher cost per kilowatt hour. To give you an example of what was in that model. So in terms of diesel and power density, we expect to be, by 28, we'll be at parity with diesel. By 30, we'll be close to 50% more dense than a diesel by square foot or hectare or whatever way you want to measure. So those are some of the numbers. Round-trip efficiency, very similar to an internal combustion engine. It's about 30% when you think about the full cycle.
Thank you.
Okay.
Iris from Visionaries Tomorrow again. I was wondering what your main cost drivers are.
Cost drivers? Well, for the capital, I'm an ex-automotive person. It's really, right now, we're driving complexity down because it's not the simplest system. So it's like that. It's complexity reduction, injection molded parts. For the fuel disc, it's really all about how we get, we've got a good manufacturing process already. It's really about how do we maximize how much energy we get out of it. Of course, you have to tap into existing chains, and that changes depending on which continent you're on. Easier in some markets than others.
But for example, like, would the main cost driver then be the fuel? Or like, if you would have to mention 1 or 2 things, what would they be?
In backup, it's more about the capital.
It's more about
because
the
you're
capital.
only being used maybe 100 hours a year, okay? So the fact that this might cost twice as much as a diesel generator per kilowatt doesn't matter. Our capital is in the market, and because you can use us, you can shrink the BESS, you can shrink the solar. So the big savings is because it's a more efficient overall microgrid, basically.
Okay. Thank you.
Does that help?
Sorry about that, but we ran out of time. Thank you so much, Rob. It's been a pleasure. We're going to start on the second or the third row next time. Thank you. Thank you, Rob. Okay, I can see our contestants are more than ready. Niall Coogan, CEO of AssetCool is already here.
Yep.
Did I say it right?
AssetCool, yeah.
AssetCool,
Yeah.
okay. Do you need your slider?
Oh, yeah, sure.
Sure. You are ready, and your time starts now. Good luck.
Perfect. Good afternoon, everyone. We all know the grid is a huge challenge right now. We've got unprecedented demand growth at a time where there's an aging grid, so you have this inflating maintenance bill with fewer people to do it. So for every 2.5 retirees, there's 1 new entrant under 25, and that's leading to record queues for interconnection in data centers. So the solution to this is, in our view, robotics. So AssetCool robotically upgrades the grid. So these are physical grid upgrades. We do this applying a spectrally selective coating. So this reflects sunlight, emits heat, lowers the temperature of overhead power lines, so you can get up to 30% more power. That is 50 to 200 megawatt uplift across certain circuits. So this is data center scale capacity additions, delivered in months at a fraction of the cost of reconductoring. So it's got unparalleled speed to power for a physical upgrade to the grid. We have robots that were employed by humans. You can see one climbing the tower there. But we're now moving to a second generation, which is drones that can take off, land on the line, and remotely deploy coating modules. So you can get this without huge construction crews. We've got significant traction. We now have 30 robots operating over 1,400 kilometers of conductor. We've worked with 20 utilities, everywhere from Nepal to Canada. So we are now beginning to deploy at scale. We've got huge amounts of test and validation, third-party test certificates. We just did a project yesterday with EPRI, who are the gold standard in the United States, and we're also able to apply in the factory. We won free electrons last year for those, I think that's relevant, but the core value proposition is this. We can add, let's say, 20 to 40% for around $60,000 per kilometer, so that is about 10x cheaper per megawatt basis than reconductoring, but critically, we can do this in months. So we got the project we did in Georgia in the US, we got contacted 2 weeks before. We can mobilize quickly and start deploying and physically upgrading lines, whereas rebuilding lines with advanced conductors, this is going to take 3 to 7 years. So super important power over the long term, but we can deliver very quickly. In terms of data centers, we're talking 100 megawatt uplift on a circuit, 100,000 GPUs, you're talking hundreds of millions to billions a year in revenue for something that can be deployed in months at a fraction of that. So yeah, one of the fastest growing companies in Europe. Incredible investors, energy impact partners, Xtantia, who are on the panel here, so if we win, that's absolutely nothing to do with it. Eluit, who are also in the room. But yeah, happy to take any questions, but thank you so much.
Thank you so much. Okay, let's start here, please.
Max Vanney from Zerocom Capital. What are the main bottlenecks to scaling and expanding your business that you're currently facing?
Yeah. So the primary one, or the slide's not gone, is that we have to de-energize the line. So we have to take the line out to put the robots on, but the drone that we've released can go on live line. So we can get to a point where, without needing an outage, which is obviously inconvenient if you're in Texas, you have huge amounts of load, you don't want to take it out for a few months, and also labor. So having linemen climb the towers, put the robots on. A live line capable drone solves all of that, and we can start to add, data center scale capacity, in utility sleep, basically.
Cool, thanks.
Yeah.
Next question, please. Let's go for the fourth row, please.
Hey there, Derek from 2150.
Hi, Derek.
What are sales cycles like, and what are the ways that you can either speed them up, or what tends to slow them down?
Yeah, classically in grid, it's a challenge. We've been building our sales pipeline through a combination of pilots, like we're still having to do occasional pilot with full circuit deployments. So that is what we call putting a fire out. If a utility has a problem that can't be solved any other way, that's catapulted us into some pretty meaningful revenue. We've got 4 million signed that we're working through now, expect 10 million booked by September. But we're also doing that kind of institutional qualification, regulatory engagement, so we can get to those network-wide deployments. So it is a long old game, but we're doing everything we need to. So probably mid-next year, we'll be into those deployment scale contracts.
20 seconds for another question.
So a quick question. I'm Takeshi from Jira. So a quick question. From the utility point of view, how often, say, call the grid?
Yeah. So coating's designed to last multiple decades. So there's not recoat every 10 years. There may be some occasional, if there's some unknown in 10 years, we can go back and surgically coat that damaged area, for example. So, but it's intended to be maintenance free.
Thank you so much. And we run out of time. Congratulations, Neil, and good luck.
Thank you so much.
Okay, now it's time to listen to Duarte Fleming, CTO of Enline. Let's give him a big applause. Do you need your slider? Okay, good luck. Your time starts now.
Hi, everybody. At Enline, we build digital twins of energy assets, grid assets, and my presentation is not prepared for what I came. What we do is grid visibility for grid operators. We started in 2020, now 2025. We have our solutions being deployed on more than 10,000 kilometers of lines. We are active in 5 continents. We work with customers such as the big grid operators in Europe. I will highlight that we won, and the project just started today, the largest dynamic line rating project ever, 1,170 kilometers in Lithuania with Litgrid, where what we do is we do dynamic line rating, which is dynamic capacity of transmission lines, similar to what the colleague before us just explained. the wind hits the cables, cools them down, so you can push more power. Big plus on our solution is you don't need to disconnect the lines. Software only. Ex-Siemens team. I myself used to work for Siemens at the headquarters, was head of AI products. And this is it. So we provide grid visibility. We have solutions to monitor the lines, build digital twins of even the surrounding area, vegetation. We have different software modules that all complement the EMS stacks and ADMS stacks for distribution customers. They're based on digital twins. They solve this information silo problem. And we aggregate all of this into a platform we call GridSight. Here's just a couple of use cases that we have in which we were able to increase the capacity of transmission by 20 to 40%. Litgrid, our customer, now reports 52% increase in capacity. And for the customers that are not yet, let's say, ready or want to test something out, we also provide services for them. In interconnection studies for data centers, bring your own energy dimension, and design optimization. Thank you very much.
Thank you so much, Duarte. Let's start with the questions. Second line, thank you.
Hi, this is Abhi from Marble. Could you tell us more about what processes you need to go through for your sales cycle? It seems like deploying this at scale through a grid could be very involved and take a long time.
Absolutely. As with my previous colleagues, sales cycles with grid operators are long. They're typically, if you're talking about large deployments, easily 12 to 18 months. Pilots, in dynamic line rating, we can do pilots with sales cycles of less than 3 months, but then rolling that out, particularly in Europe, requires public procurement, and that's what delays this. Our approach to scale that was partner with technology vendors. Something I maybe skipped. We have a global partnership with ABB, where we supply this technology for them. So ABB's dynamic line rating is ours. And we use them as channels to accelerate this. Direct business with the grid operators. We're trying now via these consortiums and Horizon projects where we don't have to sell them directly and they are part of implementing and testing this technology.
Any more questions?
Hi, Mayank from Carbon Drive Capital. I guess it's a simple one, but what kind of separates you from competition or just a utility or someone else developing something similar in-house on a software basis?
Great question. One, we do hybrid DLR deployments. So when the customer wants to have sensors for extra visibility, we provide that. They don't have that. And usually, we see grid operators trying to develop this sensorless DLR in-house. What they then lack is, one, capability to actually produce production-grade software, and then the worst part is integrating that into their systems. They usually need either a system integrator or a technology partner that allows them to also connect the systems, and that's the advantage we're capitalizing on, basically. They can do pilots, but they can't scale.
Okay, so we run out of time. Thank you very much, Duarte.
Thank you very much.
If you don't mind giving me the mic, please. Thank you so much, just in case. Okay, thanks. Okay, now we want to see on stage, please, Andy Wynn, CEO of Flexiramics. Welcome. Let's warm him up with a big applause.
Okay.
You already have a mic.
Yeah,
you already said then.
Seem to be working.
Great.
I followed instructions.
Okay, of course. Your time already is starting now. Let's go for it.
Cool. Hi, everyone. My name's Andy Wynn, CEO of Flexiramics. We make flexible ceramic materials that are revolutionizing electronics. So most people think that AI and 5G devices are limited by chips. They are not. They're limited by the materials underneath them. So all devices are built on printed circuit boards, reinforced with glass fiber. And that's been fine for decades with simple devices, but with today's high-frequency devices, that glass limits performance. It traps heat. It causes signal loss. And it's an issue that's costing the industry $60 billion in wasted energy. Flexiramics, we replace that glass fiber with our unique ceramic fiber fabric. The results are dramatic: 75% reduction in signal loss, 5 times better heat dissipation, drawing heat away from the chip. And we're a drop-in replacement, same manufacturing process. Why does it matter? Because demand for these devices, as you all know, is exploding. 17% growth a year, and glass fiber cannot keep up. Not only is it reaching the limit in its performance, there's also a huge supply bottleneck in the industry. That's why industry is looking for alternatives right now. Our go-to margin as a business is we focus where value is highest, and that today is AI infrastructure. We are partnering with PCB manufacturers to be a raw material supplier. And because we're a drop-in solution, adoption's relatively quick. So we are already in pilot production. We've got a pipeline of over 360 customers in development, and last year we started getting our first revenues. So this isn't a concept. We're already in the market. And it's a significant market. Glass fiber in PCBs is a $5 billion market. We're focusing on the high frequency part, and that gives us a $500 million market entry point. Our team combines deep materials expertise with decades of successful customer execution. We are currently raising 16 million euros, and that's to scale production to achieve our customer adoption and to turn those early revenues into commercial traction. So Flexiramics is a once-in-a-decade opportunity to lay a new foundation for high-performance computing. We can reduce cooling energy by 30%, taking out 300 million tons of CO2 from the atmosphere every year. And we are positioned to become the next foundation in electronics. So if you're looking for a high-impact investment, please, let's talk.
Thanks so much, Andy, for introducing us to Flexiramics. Great name, by the way. Let's go with the questions. Any questions, please?
Stunned silence.
Oh, you said everything. Okay, front row.
Thanks, Andy. Iris from Visionaries Tomorrow here. From all the different applications that you mentioned, like 5G, data centers, RF, is there any of these 3 that you would highlight as like, this is really my killer use case?
It is the AI hardware that is driving demand. All these producers like NVIDIA, etc., are really struggling to find the grade of glass fibers to carry on production of all their wonderful new tech. So they are, in fact, it's a 2-to-1 demand to supply. So there's a huge gap in the market, and we are moving in to try and capture that market.
And in terms of metrics, like for example, performance, but also cost savings, like what are you kind of gaining for them?
Okay, so in terms of manufacturing cost versus glass fiber production, we're around 30% lower because we have a much lower energy process. In terms of pricing to the end user, 12 months ago, we were probably 2 or 3 times higher pricing. But because of this bottleneck in the glass industry, every month there's 10, 15% price increase. And now we've miraculously come to price parity. So we produce a lot of benefit for the end user for no change. And we have a high margin as well, let me say.
Great, good for you, and thank you.
Thank you very much.
20 seconds for another question.
Very quickly, what is it about your material that's so much better? Is it, I mean, the traditional ones don't seem to be flexible.
Well, there's 2 things. So we're replacing glass fiber materials with ceramic fiber. So there's 2 effects. One is a composition. Ceramic is much better, much higher thermal conductivity. And also Glass fiber is a woven material, so it only has an XY effect. As is non-woven, so it has a 3-dimensional effect. So structure and composition.
Okay, that must be all for now. Thank you very much.
Thank you.
Andy.
Thank you very much.
And I hope you have good luck. Thanks.
Thank you.
Okay, big applause. Let's move on and welcome Amjad, Anu, Aisha, founder and CEO of Grunuss on stage. Let's warm him up with a big applause. Come on, come on. Okay, your time starts now. Thank you.
Okay. Europe's power grid wastes up to 30% of electricity through transmission losses. That's over a 20 billion a year and over a 36 million tons of CO2 per year. And the bottleneck isn't innovation, it's actually materials. And so hi everyone, my name is Amjad, I'm the CEO and founder of Grunuss. We are developing quantum simulation to accelerate and discover energy materials. And please allow me to leverage this stage not only to pitch a product or to pitch a startup, but also to pitch a moral vision that touches everyone, humanity. And that starts 2 years or 3 years ago when the geopolitical start to shift, whether here in Europe or the Middle East, when I saw clearly that politicians are using energy as a source of power and weaponizing it. So I decided to take responsibility and act on it. And so 3 verticals that we're focusing on to improve efficiencies are we see in the superconductors waste a lot of energy and money on cooling. Batteries lose capacity every recharge-discharge cycle, and generators lose energy on heat. And so classical energy systems hit their physical limits, and quantum precision hold the key to solving those problems. Scientists recognize that, but the current approach is to go to the laboratory and basically run iterative trial and error experiments on the next generation of quantum material, waste a lot of money and time. So that's where Grunuss comes in. We are creating this simulation to rapidly sense, simulate, and manipulate quantum materials. And that will unlock the next generation of energy products, whether it's room temperature superconductors or 3rd generation of batteries like quantum batteries or generators which could be superconductive. So that said is basically we're following the path as in history had showed us. If you make something abundance enough, people cannot use it anymore as power, which is food. People fought over food, no longer fighting over food because it's abundant. Same with the energy. So first pilot, we leveraging the same simulation as a predictive analysis to predict the life cycle of batteries. Currently, companies don't really know what the end of time for their batteries. That's the plan for our first pilot in the next few months, releasing this product. And the competitive analysis, we think we are our first mover because the same approach is being validated in the industry, but for drug discovery rather than the energy sector. Our team, we are building a global team which we have now 5 professors, 3 of them now presenting. One of them, Professor Mahmoud's already published 100 paper on superconductivity. Professor Radik already an inventor of hyperneural networks, and Professor David is specialist in numerical simulation. 4 co-founders and 4 specialists, business specialists. And our customer acquisition strategy start from current stage targeting customers like Cattle, one of the largest batteries corporate here in Europe, in Spain and China, moving to 50 hertz, targeting 20K this year as an MMR and growth rate of 15 to 20%. And capital, we're requesting 1.5 as a first tranche for seed round and 4.5 for the second. Full value chain start with a simulation, but we're targeting obviously in the future to develop the hardware and patent license our discovered materials. And for most, the real transition isn't from fossil fuel to renewable, it's from decision based on data to decision based on morals. Thank you very much.
Okay, thank you so much.
Okay.
Let's go straight into the questions.
Thanks a lot. Max from Zero Carbon. Could you give us a few concrete examples of the performance increases you've managed to achieve with your simulation platform?
So currently the simulation is still in development, but we decided to de-risk this model by improving the current problems in the market rather than only chasing the next generation, because we are a deep tech and we discovered that we need really to go to market. And one of the solutions that I mentioned is predictive analysis for batteries. It's not about efficiencies, but rather here it's about people don't really know how to predict the battery life cycle, and we can do that.
Thank you.
Sure.
Any more questions? Any more questions for Amjad? No? Do you want to? Yeah.
Gabriel Kra with Prelude Ventures. You didn't really even describe a high-level architecture for what you're doing. It sort of sounded like big data analyst magic button out. Can you give us a little more detail than that?
No, it's yeah, sure. It's like AlphaFold. They've done that before for let's say material discovery, but was for drugs, and they've received Nobel Prize for that. The scientist over there. So it's physical neural networks in the background that you basically encode the quantum physics equation, and that's how you basically.
AlphaFold also had a massive trove of data that they had access to. Where's your data coming from?
Yeah, that's great. So we're not the only guys who's gonna, as I said, that's why I said it's a humanity mission, not only myself. So we're now partnering. Now we have 5 universities that are on consortium. It's going to expand to 10. We now in collaboration with part of them in the process of EPFL, CCAM. They have 30 members globally. So we want to get those universities on board, a lot of them, so that we can first have a data partnership with them, and also from the customers. So we want to improve the current problems that we have in the industry. So we reach out to customers, we collect data from them, and we solve their problems through this simulation.
Thank you so much, Amjad.
Sure.
That's all for today.
Sure. I'll leave that here.
Yes, you can leave it. Okay.
Thank you.
Thank you so much. So, and next in line is Rishabh Manjunatha, Chief of Staff at IONATE Limited. Here you are. Thank you so much. And your time, let's wait until the countdown is set. Okay. Thank you so much.
Thank you. We're living in a time of game-changing innovation, from quantum computing to AI and the electrification of everything. Yet the infrastructure that powers all this hasn't changed in over a century. That causes inefficiencies, blackouts, and hundreds of billions in economic losses today. Yet the biggest cost is in the opportunity cost. This aging system simply limits what we can build on top. My name is Rishabh Manjunatha, Chief of Staff at IONATE, and we decided to fix that. First, we invented a new building block. We call it the HIT, the Hybrid Intelligent Transformer. It looks and connects just like a traditional transformer, but it has a brain, and that adds 2 new functions: real-time visibility and power flow control. Suddenly, this basic building block becomes a Swiss Army knife, both for the grid, but also the big things connected to it. One of the biggest ones being data centers. Today, their power stack is lossy, fragmented, and requires a lot of maintenance. With the HIT, we found a way to merge magnetic control with solid-state electronics, which brings all the benefits of SSTs, but without the downside. It provides perfect power quality, but maintains that reliability and efficiency of a traditional transformer. This improves PUE by up to 5%, saving millions on CapEx and OpEx with each deployment, and a ton of space for what matters: compute. Each HIT autonomously cleans up its local power flows, but in doing so, they become real-time control nodes. And once we have a fleet of HITs, IONATE's AI-enabled software can coordinate them to unlock a system that's inherently adaptable, handles variable power safely, and eliminates losses. A truly intelligent network. Now, to make the most of this opportunity, we didn't want to build gigafactories. Our tech is ready, and the time is now. So we partnered with established transformer manufacturers who build the body, the transformer, and we, IONATE, supply the brain, the electronics, kind of like the Intel Inside model. With gigawatts of manufacturing capacity together, we can deliver in months, not years. We have projects and grids across Europe, such as Spain, Portugal, and Austria, and we're building for big power users in CNI and data centers in the US. We're moving fast because we're facing massive market pull, and it's no wonder. We can't power AI without better energy systems, and power infrastructure is our biggest limitation. So we're ready to turn it into the biggest enabler. Thank you.
Okay. Thank you so much. Let's go for the questions. We have one here.
Hi, Abhi from Marble. I'm curious about your manufacturing. You said you're partnering with existing transformer manufacturers, but here you're assembling electronic systems with electromagnetic systems, quite different from the perspective of the manufacturer. Can you tell us more about the performance metrics you've achieved on the manufacturing side?
Yeah, one of the advantages we have with our technology is that we can utilize existing technology that transformer manufacturers have, existing supply chain, but we bring the IP. The advancement is in the arrangement of the magnetics, but also the addition of the electronics. And we work with partners on the electronics to build that to our spec with our control for the best possible performance. And we also work with the manufacturers who build the core so we get the best possible product. So that allows us to bring a product to market that's ready today, that customers can meet the same efficiency requirements as the traditional transformer, but they get all the benefits of having solid-state electronics.
Derek from 2150, what does your revenue model look like, especially if you're contracting out manufacturing? Is it just on the software application?
So software is definitely one angle, and it's kind of positioned as a SaaS model where we go direct to customers. We can offer more functionalities with the hit with the software, so unlocking greater capacity, coordinating hits in a network where we have multiple of them. But on the hardware side, because we own the IP, we can go to manufacturers in a licensing model. We work with them. There's a royalty that's included in that, but then also a share of the final cost to the customer.
15 seconds for another question.
Moritz from Future Energy Ventures. What's the sales cycle and how's the interest from TSOs, DSOs so far?
So we are focused on distribution networks. So DSOs would be a very good customer for us. But there are 4 key market segments for us. So utilities is one big one, but there's renewables as well, industrial customers, and data centers. Data centers are a really good focus for us right now because they're moving fast. And there's a lot of interest for us in Europe, but particularly in the US. And we can focus on that for the time being and get products into the field in customers' hands. But we already have projects with utility customers in Europe.
Okay, thank you so much. Thanks. Thanks, Rishabh. Well done. Okay, next in line is Arthur Bud Voss, President and CEO of MetOx International. Welcome, the stage is yours. Your time starts now.
Wonderful. Good afternoon, everybody. I hope everybody's doing well today. I hold in my hand in front of you a conductor that will change the world. This is high-temperature superconductor material that's 12 millimeters wide, 100 microns thick, and that'll carry close to 800 amps of current. If you tried to do that with a traditional copper conductor, it would be about the size of your arm. Let me tell you a little bit about MetOx. As we're progressing today, we're in a race towards a massive confluence between power density and the availability of copper. It's been estimated that by 2035, even up to 2040, we're going to have a massive shortfall of copper in trying to build out our infrastructure. This comes from all types of different sources, from power generation to power delivery. High-temperature superconductors alleviates this. HTS, and our brand of HTS is called Zeus wire, transmits over 250 times the amount of power that a traditional copper conductor can in the same area, leading to all kinds of advancements in terms of deployments. We work today in 6 very diverse markets. Everything where you see high magnetics or power delivery, you can yield and deliver with a superconductor. This goes from everywhere from aerospace and defense to some of our more common markets in power conductors and power transmission, where products have been deployed around the world many, many times over, and now into places like fusion energy. The market is extraordinary. As we continue to see it grow, right before our very eyes, we see this growing to over a $30 billion market, captured across those very diverse areas. So we're not dependent upon one single type of customer or one element of that market demand. We're growing along with them. MetOx as a company is very mature. We've actually built and proven out this technology and operate a production facility in Houston, Texas that produces 1 million meters of material on an annual basis today. That plant has allowed us to launch into building our second facility, which is a 5x scale up, and we've secured $120 million of capital already in place to build this scaled up facility. And we'll be moving forward as we go forward later this year into an additional equity raise for the company. We have over 150 years of experience, and one of the key differentiators in our technology over others that produce this material is the ability for us to produce at about 48 times the scale of most traditional technologies. Our roadmap is simple. We've brought the product to production and commercialization, now delivering to customers off of the plant in Houston, and we'll be now moving into a scale-up phase for the business with that 5x expansion. We have an amazing execution team. We built this plant in under 11 months. You can see left-hand side, complete empty factory, right-hand side built. One of my favorite quotes was from one of our best investors who said, "You built that on China time." An amazing team from all around the industry, semiconductors and clean tech, that has come together to build Team MetOx. Thank you.
Thank you so much. Let's go for the questions.
Thank you. Max from Zero Carbon. What does your material consist of and how mature are your supply chains?
So this is a rare earth superconductor. It's a yttrium barium copper oxide, or YBCO. So we do use yttrium in terms of the actual substrate of the superconductor. Out of that 100 micron thick piece that I showed you, only 2 microns of that is the actual superconductor, so 2% of that full thickness stack. Our annual usage, I could put in a 5-gallon bucket right here on this stage, would feed our plant for an entire year. So very, very little actual usage. We don't back rail cars up to the plant to feed it.
All right, clear. Thank you.
Thanks. We still have 1 minute. Any more questions, please? Okay, here, please.
I knew Gabriel couldn't resist. Hey.
I'm Gabriel with Prelude Ventures. Can you actually dive in a little bit more on the market segments, like who's really using this stuff right now and who's using it in the future?
Yeah, so I'll give you 2 examples that I think are important to understand the scale of the market opportunity. If you were to look in the fusion space, which I realize everybody might say, oh, fusion, that's kind of interesting. There's about 40 companies today chasing the fusion dream. 23 of them do this through magnetic confinement fusion, so they're building a magnet, and they use this material to create those magnets and coils. The most common out there is Commonwealth Fusion. Everybody knows Commonwealth. They're building a large plant. They already have PPAs and offtake committed for that plant in Virginia. That fusion reactor, one single fusion reactor for 300 megawatts of output, requires 20,000 kilometers of material. That's 20 years of production out of that one plant in Houston. So that is an example of just one. When you start looking at the number of fusion reactors being built, that's one use case, one place where we see that. That's the way we build that market assessment up across all 6 segments, is starting with those base fundamentals.
Thank you very much, Bud. That must be all for now. Thank you. Okay, let's welcome Patrick Huembeli, Director of Advanced Computing Lab at Noumenal Labs. Here you are.
Thank you very much.
Thank you. All set? Let's go for it.
Is this on? Well, yeah, I'm Patrick Huembeli. I'm a founding research engineer at Noumenal. Our CEO, unfortunately, she couldn't make it today. We have some customer engagements in Texas. It's also why I'm very jet-lagged. Robotics is hard. It's not just hard because it's hard to build a robot. It's also hard because we don't really know yet how to deploy 100, 1,000 robots, because each robot has a failure, a mode of failure. It encounters an out-of-distribution moment, and it doesn't know what to do. So how do you deploy robots at scale? Sorry. Now. And this is why we built the so-called ThermoBrain. It's a platform for active intelligence for autonomous systems. It's a probabilistic stack that allows us to trigger a signal to the user to tell the user or the teleoperator that a robot is uncertain about something, or we can even do world modeling and anticipate future confusing moments for the robot and tell the user to intervene. Since this is a compute summit, I put this slide on. So this is about architecture. There was a lot of discussion this morning about this. We're working together with a global hardware company to build this stack, to have like our edge devices, the robots, and near edge servers on the premises. Because the probabilistic stack is demanding, and we want to run this at least possible inference time. And this is what we developed together with this provider. Our first vertical we're focusing on is solar farm vegetation management. This is a hard environment. It's outdoors, it's back-breaking labor, so there's a lot of demand for this. There's a trimming task around the poles, so it requires fine control for this trimming. There's a lot of reasons why this is a hard problem, and we're focusing on this. It's also GPS denied under the panels. This is our prototype, Whiplash. Unfortunately, we cannot play videos here, but I'm happy to show more. So we have some from this Monday, actually, from the farm in Texas, where we do first deployment tests with a customer. Oh, there's one slide skipped. Well, anyway, so the market is big. We work together with a company called South Texas Curbing. They're the biggest provider of vegetation management, solar vegetation management in Texas by gigawatts. And they're really looking forward to start this pilot with us because they cannot staff the labor to actually do that. We're looking for a round of 2 million. But we're also here because we want to get in connections with European solar vegetation managers or also farm developers, and we'll be very happy to chat more about this after this.
Thank you so much. Do you want to finish very quickly?
No, I think it's a team. We're a team of our CTO was at Microsoft. He's the builder. We have Maxwell Ramstead. He's the intelligence behind active inference, which is part of our stack. Candice, unfortunately, not here today, and me, Patrick.
Thank you so much. Shall we go for the questions then? Let's go for it. Yep, questions?
Hey there, this is really exciting stuff. Gabriel Kra with Prelude Ventures. You actually described, it felt like two different technical problems. One, you described a problem of humanoid robotics training that's trying to build a generative model where people can't get enough data by using telemetric approaches to train the model. And then you described your first product, which is a deterministic solution where you could actually do some much more traditional programming to tackle the problem of trimming the bushes in a solar field. So is one a stepping stone to the other? Are you doing two separate sort of technical pathways?
No,
How can you talk about that?
It is definitely a stepping stone. So I mean, the probabilistic stack of like solar vegetation management obviously is simpler than it will be for humanoids, but the idea of like triggering signals to the user is the same. So the platform that we're building, the teleoperation platform, is there to trigger signals to the user to say, hey, here's demand for or the robot is uncertain. What's happening on the robotic side is obviously simpler. We don't do like dreamer kind of world modeling that we would do on an arm, for example.
30 seconds for questions. Anyone?
Exactly, yeah. That's the whole point of it, yeah, the intervention. And the intervention becomes signal. Exactly, live. Yeah.
Okay, that's all then. Thank you so much, Patrick. Okay, we still have 4 more presentations before we finish. Let's welcome now Joshua Benjamin, co-founder and network architect at Oriole networks. Welcome. There's your slider. All set, and let's go for it.
Good evening. So there's three key elements that impact AI system performance. There's the compute, the storage, and the network. Compute and storage are moving rapidly, and they're advancing year on year. But the network performance is being left behind. So eventually, what's going to happen is that GPUs will do the computation instantly, but will wait around and idle, waiting for data to be delivered from the network. So this really is the bottleneck. So why is the network such a problem? It's the way it behaves. It's the way networks are built. So the way networks are built currently is that if you have two racks, data goes from the source rack to the destination rack through a series of hops on these switches. And when the network is congested, the hops, you have to hop and queue and wait around, and that's what creates the latency. So what we have right now is an electronic network that is power hungry and very laggy. So this is where Oriole Networks comes in, and we have the world's first pure photonic network. So what we do first is get rid of all these different electronic switches in the middle, and we equip each GPU with the switching capability. By choosing the color of light and the route at the edge, at the GPU, it can talk, the source GPU can talk to the destination GPU with a nanosecond reconfiguration. So because we get rid of this core, we have zero power, zero cooling, and zero latency. So we're not a component solution provider. We give the entire platform. So we do the network offloading elements, the pluggable that does the switching, the wavelength selection and the transport, and also the passive router. So if you take a conventional, so we've got the latest, this is an important plot. It's got the latest NVIDIA AMD systems running on the latest electronic networks. And if you introduce the Oriole network solution, then you get massive improvement in throughput and connectivity. So this is our competitors, and they all give component-based solutions, but we are in par with Google, giving a complete all-around solution. We've raised $50 million already, and in Series B, we're looking for $150 million, and our funding just opened this week. So Oriole is a top contender when it comes to network building, and we want to build it best and fast. Thank you for listening.
Thank you so much. Let's go for the questions.
Mike. Mayank, Carbon Direct Capital. If Google is kind of your comp in that kind of upper right quadrant, how do you plan to compete with them, or what do you have that's different than theirs?
So they have optical circuit switches with them, but they are switching at much slower speeds in milliseconds and microseconds. So when it comes to this particular solution, where it comes to connecting large-scale networks, we're better than Google. So we provide we take nanoseconds to reconfigure the entire network. Even if it is 1 million nodes, we can reconfigure in tens of nanoseconds. Yes.
Hi, Iris from Visionaries Tomorrow. Are there any specific infrastructure changes that are needed for your customer to adopt this solution?
Yes, definitely. So we give the entire stack, but you can replace it. You don't have to go all out and replace the whole thing together. You can do it cluster by cluster basis. Our solution is very good with providing high throughput and low latency. So for such applications, you can replace one cluster, see how it performs, and scale at will.
Thank you.
We still have 30 seconds. One more question.
Gabriel.
Did you say you have to put the optical interconnect on the GPU, but then you also referenced like the Vera Rubin racks, and NVIDIA is selling those as full racks. So do you have to integrate all the way back to the packaging of the chip or something like that? Where do you have to integrate with an NVIDIA Vera Rubin as an example?
So with the NVL72, the whole thing, rack, and with the Rubin, they all perform together when it's tightly spaced and coupled. So their CPC solution makes it all good anyway. The problem is when they go outside the rack.
From the rack.
Yeah, from the rack outside. And that's where we come in and we introduce XPO solutions so that even outside the rack, you're able to scale and, scale and perform.
Okay, thank you so much.
Thank you.
So, and I can see our next contestant is already ready to go on the floor. Welcome to Elisabeth Ortega-Carrasco, Product Manager and Solution Architect at Qilimanjaro Quantum Tech. The floor is yours. Here's your slider, and let's go for it.
In the microphone. Okay, I will start.
Okay.
We all use AI, isn't it? It's very easy to use. You only have to type our device, write the prompt, and as ever located anywhere in the world, we'll start processing our request in a way that is totally transparent to the user, but is not transparent to the planet. As the number of requests grow, the infrastructure needed to run it also increases, as well as the power consumption. Just to give some numbers, it is written that they say that in the 2030, the 25% of the nuclear plants around the planet will be used to power AI data center. And this solution doesn't scale. In Qilimanjaro, a full-stack quantum computing company based in Barcelona, we have an alternative solution: analog quantum computers installed in data centers. And this is not a hype idea. This is something that we already make. And here you can see them. There are the 3 quantum computers that we install within a chapel in Barcelona Supercomputing Center, one of the most powerful data centers in Europe. In Qilimanjaro, we strongly believe that the combination of quantum computers and supercomputers will push the AI due to the new computational paradigm that they have, but also for the compute power that they need. All these 3 need the same power than just a simple AI rack. And in Qilimanjaro, we strongly believe again that that will be the future of data centers. And we are proving that. And you can also prove that. You can have a request, you can access to a quantum computer and build your use cases there, and we can help on that. This year, we will release our Quantum as a Service. That is a subscription model for cloud access to the computers that we have in our lab, not the ones that are in the screen, another 4 more that we have in our headquarters alongside the classical resources. And we cannot do all the things without our fantastic expedition team, that all together we work hard to sum up 20 million of accumulated revenue in all these years. This team is managed by a fantastic management team, and heterogeneous in background. We have chemists, we have computer engineers, we have MBAs, and of course we have physicists, all of them pushing the company towards the same direction, following the growth plan. We started building our technology, which is now putting the technology in the hands of the user to accelerate adoption at the same time that we are building powerful quantum computers to culminate with the industrialization of quantum computers within data centers. Our vision attracts investment, and investment is helping us to grow. Last year, we closed a seed round of 10 million that help us to build the quantum data center that we have in our headquarters. And now we're on the verge to close the Series A of 50 million that will push up, will help us to reach the next level, bringing analog quantum computers to the world for a sustainable future. Thank you.
Thank you so much, Elisabeth. Okay, so who's going to make the first question? Yeah.
Thank you. Iris here from Visionaries Tomorrow. You mentioned on the last slide there were these 3 phases, right? And you're currently executing phase 2. What are the specific technical or commercial things that still need to happen before you can start with phase 3, actually, like the big vision where you have industrial scale quantum data centers?
This is the current state of the technology, but not only in our company, it's around all the quantum computing company at global level. The computers that we have nowadays, they are still in the early stage. They are also noisy for the case of the other IBM and so on. They use a digital paradigm. In our case, they are too small for the moment because they are very difficult to make it. Our researchers are reinventing the physics every day that they are in the lab. So this is why, with the quantum computer that we have now, that there are enough to explore, we will give to the users this power of accessing our cloud service, at in the same time, still working in the evolution of these quantum computers. And now we have one chip that will read us to then we'll know quantum advantage, we can start industrializing it a little bit better.
Thank you. And for phase 2, like, who are the specific customer profiles that are interested in quantum as a service? Can you give some examples?
We have university, we have a student that is, for suppose, but we are targeting the innovation departments of big companies to show them how they can improve their workflows using quantum computers. So we have a service that is called Quantum Exploratory Services, that we go with the customer and we build the use cases with them.
Okay, thank you.
Maybe, nope. Yeah, that's all then. Thank you so much, Elisabeth. Okay, and coming up on stage already is Caterina Tabaglione, Commercial Partnership Lead at Quix Quantum. Welcome.
Hello.
Here you are, and go for it. Thanks.
Yes, thank you. So, quantum computers are a new computational paradigm that is needed to solve problems that otherwise will remain impossible to solve, right, for eternity. But to deliver a practical quantum advantage, quantum computers need to scale and needs to do it efficiently and as well while obeying infrastructural requirements of today's data center. Now, most quantum computers modalities require specialized environment. I guess you're all familiar with the big chandelier of IBM and Google, right? And they bring with it a huge infrastructural burden, which makes it hard to deploy, scale, so interconnect them, and maintain. Now, Quix Quantum solves all these challenges with its architecture that provides the lowest total cost of ownership for quantum computing. Our approach has the lowest technical risk and the lowest capital path to achieve 100+ logical qubits. How do we do that? One, we leverage existing semicon fabs, which means we can scale with volume. Two, with our proprietary error correction methods and technology that provides the lowest qubit noise, we can scale efficiently, meaning, in simple words, we need less hardware to achieve the same amount of qubits of other modalities. Three, our system works maximally at room temperature, making the full computer sustainable and as well able to live in the same conditions of HPC data centers and data centers. Four, our quantum computers can be connected and therefore scaled by just plugging in optical fibers, telecom-grade components, which means we can scale fast. We have a growing product portfolios that today is focused on research, academia, and national program testbeds, starting from Alcor, our quantum processors, via our special purpose quantum computer that's available on the cloud, and Carina, that's the world's first universal quantum computer. How does the go-to-market look for the future? We will pivot from Carina up to Daedalus architectures that are our fault-tolerant quantum computer. And with our Series B that has opened, and we are aiming at closing it summer this year of 100 million investment round, will bring us there. We have a proven commercial traction. We have more than 15 systems running in the field today, a close deal with the German Aerospace Center to deliver the Carina system, so the world's first universal quantum computer, and a signed backlog of 8 million, showing a strong commitment from our customer and a growing market. All of this is possible thanks to our 50-plus team spread across Netherlands, Germany, and Italy, and our leadership team with this deep expertise in quantum, photonics, and commercialization. Thank you.
Serena? So, questions for Katarina?
Thanks a lot. Max from Zero Carbon. At a very top level, what are the main technical challenges you still have to overcome?
Losses, if I could say. That's the main source of noise in a photonic system compared to the other qubit modalities. And that requires, let's say, many iterations of the underlying platform, of the underlying material, or the underlying technology. And that is what we have partially solved already for the delivery of Carina that is happening now in end of May to the German Aerospace Center. But then we have to bring to the highest quality, let's say, even further to achieve data load. That's the logical qubit system.
Right, and what kind of timelines are we talking about here?
What kind of?
Timelines, how long will that process take to reach?
2028.
2028, okay, thanks.
45 seconds, any more questions? Yep, no? Okay, that corner there, front line. No more questions? You want to use the time, 30 seconds?
Oh, 30 seconds. Oh, no, just ask me a question, random question.
Okay.
Yeah, go ahead.
What is your core underlying quantum technology?
It's photonic integrated circuits, silicon nitride waveguides. So we use integrated circuits, right? It's basically glass chips with silicon nitride in between, and that basically you can guide light with this. You can generate light, you can manipulate, you can entangle it, and then you basically do the computation over photonic integrated circuits. So it's basically chips like, they look few centimeters by few centimeters, basically.
Okay, now we are done. Thank you so much,
Yeah.
Katarina. So, and we are heading to the end of this intense session. I know that it's very tiring, but we still have one more contestant, so keep up the concentration and let's give a big applause to Stefan Hermann, CEO and co-founder of Reverian. Here you are. There you go.
Hi, everyone. Final one, but last but not least, I'm Stefan from Reverian, and we are making the most efficient power plants in the world. So everybody knows currently the constraint for data center deployment is power, at least the biggest one. And yeah, that has several angles to it. It's just the power grid access. It is also the resilience. So the power has to be there at 5.9 availability. And also, the cost is not the biggest part of the data center, but it's rising. Now, here's where Reverian comes in. We can provide 24/7 on-site power generation based on natural gas, hydrogen, biogas, whatever you want, at the highest possible efficiency. We've already units running commercially at 74.2% power conversion efficiency. And you can, of course, do that behind the meter, so without a grid, already including carbon capture by design. So that offers you a unique product that has a higher efficiency than you can find with any other product in the world, lower cost, through lower operating cost, and of course, behind the meter, so more resilience. And just to compare this to the existing solutions in the market, primary power deployments today are combined cycle gas turbine power plants, if you can get them. Then there's a company that has risen quite significantly in the past year, which is Bloom Energy, that is using solid oxide fuel cells that can convert about 60% of the gas fed to them into power, and do that in a modular way. And what we have essentially done over the past 11 years is to develop a new generation of this kind of power plant that has an advanced architecture and that can do actually power conversion at up to 80%. So from the same natural gas input, 100 megawatts, you get actually 80 megawatts of power. Plus, you get pure CO2 as an output, and pure water, which can also play a big role in cooling. So this is a unique offering that you cannot get anywhere else. We already have sites operational, not for data centers, but actually in biogas in Germany for now more than 70,000 operating hours. And we have a very strong team that has already proven it's able to scale. We are now more than 200 employees. We also have more than 2 billion commercial pipeline outside of data centers, and the interest for data centers is massive. What we're lacking is scale. So we have already raised more than 100 million, but we'll need more to actually be able to execute on the data center case. So we're raising Series B. If you want to be part of this, happy to talk. And let's go make more efficient power plants. Thank you.
Let's go straight into the questions.
Hi, Abhi from Marble. Talking about scaling, what's your biggest material bottleneck in your manufacturing of the fuel cells?
So actually, we are not making the fuel cells. We buy fuel cells. We have 7 different suppliers, but they have actual capacity constraints, so they need to scale with us. So at triple-digit megawatts, at some point there will be a bottleneck. Material-wise, it's not that bad. So it's mostly steel and some ceramics, but they are not very rare.
Mayank from Carbon Direct Capital. Could you just elaborate a bit more on why you're different or better than Bloom and how you're able to get higher efficiency?
So we actually use the same type of fuel cells. We don't buy from Bloom, but from others. But the main difference is that we have a sort of process design architecture that actually has a few hundred differences to them. Main thing is that we can use the gas more effectively inside the whole unit, while essentially we are using the same fuel cells. Yeah. But it's sort of a process design of the whole architecture that's very different and has also quite unique sort of controls and everything.
30 seconds. One more question. Yep.
So you're buying fuel cells from other producers. Do you have competition on getting on their order book from your own competitors?
Not really. I mean, there are other people building fuel cell power plants, but they have different issues in scaling rather than the fuel cells. So it's actually not that easy to build fuel cell power plants and make them live. So yeah, this is not the biggest challenge. It's rather that they need to expand their capacity.
And are you still interested in the biogas industry?
Oh yeah, we will be scaling in that too. It's also a massive market, like alone Germany is 800 megawatts a year retrofitting existing installations. So that will be remaining a big market for us. But I mean, data center is 270 gigawatts in the US alone to be commissioned in the next few years. So that's another like bigger animal. Huh?
Thank you.
Okay, Steven, that's all. Thank you so much.
Thank you.
And you just closed the pitching sessions. We are done. So the jury will need a little bit of time now. I know it's not going to be an easy decision. All the pitches have been fantastic. We're going to give them a few minutes. You can have a little break, but please don't go too far because it's going to take only a few minutes. Stay around so we can let you know when we know the winner. and who's, yeah, we will know very soon who the winner of the Ultimate Compute Challengers 2026 is. Good luck to all the contestants, and thanks all for joining us.